Welcome to my ENCMP 100 project, Clue Mastermind. Clue is a board game released in 1949 and made by Hasbro. The goal is to use process of elimination to figure out this murder case. There's so much more information that you can collect that may not seem clear, and the goal of the program is to optimize that to the max. My program can be split into 4 parts. We have the pre-game phase, and then parts 2 and 3 are active data, kind of round by round, the inputs and outputs, and then part 3 is how that data is manipulated and extrapolated. And then part 4 is what's actually outputted to the player and the feedback they receive. The way part 1 starts is it creates lists in this one variable, and it's organized in a specific way. We need an amount of players. So first we ask the user how many players, and the official board game works between 3 and 6, so that's what we ask for them. Then we're going to ask the user for names. Once we have the names, we need the cards that each player has. In total, Clue has 21 cards, and 3 of them go in this confidential envelope. That leaves 18 cards. And then we're just going to need to ask, well, what cards do they have? After we ask for what cards every player has, we add them all up, and if it equals 18, we're good. If it doesn't, we make the user go back and check. And with that card data, we can just store it in the second column of the first list, and that just represents how many cards the player has. We don't actually know which of the players the main user is, so we just ask them, which one are you? We put a 1 in the first column of the first list. Now that we know who the main user is, we actually can figure out what cards they have. Once we figure out what cards we have, we can just write a 1 in those lists. If it's a 1, we know they have it. If it's a 0, we're unsure whether they do or don't. And if it's a 2, we know they don't have it. Now it goes on to the actual round by round game. So this is where part 2 and part 3 come into play. And they actually happen simultaneously, and I am going to start with just a little bit of part 3. If a player has a 1 for a certain card, which means we know they have the card, then we can obviously write off that nobody else has the card. So now that we have the 3 1s written down for our 3 cards, we can write a 2 for everybody else for these 3 cards. 2 is the active round by round inputs. So we're going to start by going through a loop of all the players, and that's just going to continuously go. We're going to ask, what was that accusation? It has to be 1 weapon, 1 suspect, and 1 location. And from there, we ask who disproved the accusation itself. So once somebody disproves an accusation, then we're going to store those 3 cards in a tuple at the end of the player list. And this just represents a past guess that they've disproved. Last but not least, we need a little bit more input when we make the accusation ourselves, because when we accuse, then we know the exact card that was used to disprove. So part 3 can be broken up into what I like to call active data and then passive data. Active data uses the actual round by round inputs, being who made the accusation, who disproved what. And then the passive data, all it takes is the player list variable. So our first active data function is called can't disprove, and it simply just checks if an accusation has passed somebody and they weren't able to disprove it. Now our other active data function is called only option, and it just checks if they don't have 2 of the 3 cards. Okay, and now with our passive data, we have 5 functions in total. So our first function is actually the one I referenced back in the start of part 2. It just checks if a player has a 1, then it will write a 2 for every other card, including the confidential. Our second function is called check complete, and it checks just one specific player list. If they have the card amount of 1s, then that means we know all 3 of their cards. So we can write a 2 for everything else, or vice versa. If we know they don't have every other card, then we know they have the last 3. Okay, past check, it checks the 3 past guesses, and if 2 of them are written down as a 2, the last one is 1. The card only option checks if everybody except for 1 has a 2 written down for a specific card. Then we write down a 1 for the last person. Okay, the final function, first of all, it checks if there's a 1 in one of the either weapon, suspect, or location categories. And if we have a 1, then we can just write a 2 for everything else. We know it is that specific card. And vice versa, if we have 5 of them crossed out, we know it's the last. Part 4 consists of the feedback and outputs given to the player, which will actually help them make their guesses. So the way we output the feedback is basically giving them the array that the data is stored in, but in a bit more readable of a way. Underneath that, we list their past guesses in case you need to infer something off of that. So eventually, as the round goes on, players make their guesses and accusations. We'll figure out that there's a 1 written in every category for the confidential envelope, and that means we can make our final guess. Thanks to everyone watching. Good luck to everybody else.